The Standard Model Lagrangian is often plastered all over the internet and it looks extremely daunting, so let me try and explain to you in simple terms what this object is and what it describes as a theory of the quantum world. The Standard Model is a quantum field theory, which means that it describes the interaction of objects on the quantum scale in terms of different types of fields that permeate throughout all of space-time. These fields, however, behave very differently to the classical fields that you might be familiar with, such as the electric and the magnetic field, or even the gravitational field. To calculate what happens during these interactions, we use something known as the path integral or the generating functional, which is constructed from the Standard Model Lagrangian itself. Now we can actually understand what each of the terms in the Standard Model Lagrangian mean by studying a much simpler quantum field theory, namely the theory of a single scalar field interacting with itself. So this is the Lagrangian for such a theory, and you'll notice that the terms in this Lagrangian can be divided into two parts, those that are quadratic in the field, so a product of two fields, or those that are higher than quadratic, so a product of three or more fields, so cubic or higher. So the distinction in these two types of terms is very easy to state. So those that are quadratic in the field describe the free propagation of disturbances within that field, so how a disturbance propagates from one point to another, and this manifests itself during calculations as a term known as a propagator. But the terms that are cubic or higher describe the interactions of that field, either with itself or indeed in the case of the Standard Model, with the other fields that are present. The phi cubed term in this Lagrangian is therefore telling you that in this quantum field theory, the only interaction that we are allowing is the one where free field quanta of this scalar field interact at a single point. One important feature to understand is the coefficient of this interaction term, lambda, is telling you how strong this interaction is and is referred to as a coupling constant. Now, of course, there are some subtleties involved with the Standard Model Lagrangian itself, but you really can break it down into terms that are quadratic, which govern the free propagation, or those that are cubic or higher, which is encoding the interactions of the theory. And so let's finish off with a couple of examples. So here you can see this term that appears in the Standard Model Lagrangian. It contains 4 gluon fields and thus describes 4 gluons interacting at a point. And finally, we can see this term that contains a W plus with the index downstairs mu, the Greek letter nu with the index upstairs lambda, and an E, which is representing the interaction of a lepton and a lepton neutrino with a W plus boson.